everyone. Today we're talking about section 11.4. We're talking about circumference and arc length involving circles. This will be a brief review video since most of the visuals were done in class using the tire of the bike in regard to circumference and revolution. So some of this video will not, or I should say some of the stuff in class will not be covered in this video. So for this first problem, we are going to find the diameter of a circle whose area is 254.34 square centimeters, and we're going to use 3.14 for pi. We're going to do that continually unless the problem says to do otherwise. So we know the area, and we want to find the diameter. So let's use our area formula of a circle. The area equals pi times the radius squared, not the diameter. But if we can somehow find the radius, we can multiply it times 2 to give us the diameter. Basic problems regarding area and circumference of circles was included in Chapter 1. Whether or not it was in the video or was done in Chapter 1, and you've been doing it for quite some time, so I will not do the basic problems in the video. But for this problem, we know the area is 254.34 square centimeters, so that's A. We don't know the radius. I'll just leave it as R as a variable. Now to solve for the radius, I need to get rid of pi, so I'll divide both sides by pi. In this problem, 3.14, and so these pi's will cancel, and I end up with r squared equals 81. Well, to undo a square, we square root, so 9 is going to be the radius, and if 9 is the radius times 2, your diameter is 18, and these are in centimeters. And we've done problems like this in this chapter and in Chapter 1, so not too complicated. Let's move on to something else. So, using circumference to find a distance that you traveled. So for this one, we're talking about tire revolutions, which is what we looked at in class with the bike tire that I brought in. So the dimensions of a car tire are shown at the right. To the nearest foot, how far does the tire travel when it makes 15 revolutions? Well, as you remember from class, 1 circumference equals 1 revolution. If your wheel rotates 1 complete time, then that 1 circumference is the distance that you have traveled. So in this case, we need to find the circumference before we can find out how far we traveled. So in this case, we know the entire diameter by adding 5.5, 5.5, and 15, so our whole diameter is 16. So to find the circumference, it is pi times 26, and not 16. And using 3.14 for pi, give me one moment, please. So we'll take 3.14 times 26, and that equals 81.64, and that's in inches. So that's 1 circumference. That means that 1 revolution, we've traveled 81.64 inches. So 15 revolutions, we'll multiply this times 15. And this times 15 will give us a result of 1,224.6 inches. Well, to turn inches into feet, we know that 12 inches are in 1 foot, so you can do a conversion factor of 1 to 12. 12 inches, 1 foot, inches cancel, or you could do just when you divide by 12. And we end up with 102.05 feet. So again, you can use circumference to find distance traveled. Another example involving this was using circumference to find out how many revolutions. And the relationship between the circumference of your tire and revolutions and distance traveled, that's how odometers work. An odometer will see how many times your wheels have turned, and that'll tell you, the computer in the vehicle, how many feet or how many tenths of a mile, how many miles you traveled. So this is actually how an odometer works. But let's move on to something a bit more challenging since we've covered this in great depth already in different chapters, and you've been doing this for years. We're going to talk about arc length. So in a circle, we know we have a circumference. If we want to find a piece of that circumference, that's the arc length. So let's say we want to find the arc length of AB here. That's a piece or a fraction of the circumference. So to solve for that, we have a very basic setup. This red is called our arc length. And there is an angle that forms our arc length. You have 2 radii that come out from the center, and this angle in here is called your arc measure. And this arc measure is used to calculate the arc length. So again, arc length is a fraction of your circumference. Your arc measure is a fraction of the entirety, which is 360 degrees in a circle. So the arc length, the part, over your circumference here, the whole, equals the arc measure, the part, over 360, the whole. So we set up this kind of proportion, the part over the whole with the length and the part over the whole with the degree measure. And that allows us to calculate the arc length. If you were to multiply by the circumference on both sides, this would get, crossed out here and added up here. You'd have something like this. So the arc length equals the fraction of the circumference. That fraction is with your degrees. You can look at it either way, both of which will be sufficient to solve some problems, which is what we're about to do. So for part A, I'll do this both ways just so you can get the illustration. So we want to find the arc length. So here, if we want to find the arc length of AB, we'll call that AB with our arc symbol above it. So the arc length of AB over the circumference, 2 times pi times our radius, which is 8, will equal the degree portion, 60, over 360. You could also set this up as the arc length AB equals the fraction times your circumference. And if you cross multiply over here or just multiply these over here, either way you will end up with the same result. It's just a matter of personal preference. Now, before we go any further, let's simplify some things. We can simplify the fraction 60 over 360. That's actually 1 over 6. So when we cross multiply, this is a bit easier to work with. We can also simplify 2 times pi times 8, which is 50.24. When we're using 3.14 for pi. And either way you do this, we will end up with the same arc length, which in this case should be about 8 point. And let's use 2 decimal places, so 3.7. And this is in centimeters. Just as you would measure circumference in centimeters, you will measure a portion of the circumference in centimeters. Let's skip B and let's move on to C. So to find our arc length, that's the fraction, which is in this case 120 over 360, and it just made the same mistake that every class made. In this case, we're not talking about AB, this is GH. And that's going to be times the circumference, which is 2 times pi times 11 in this case. And 120 over 360 is 1/3, so you could simplify that. So 2 times pi times 11 times 1/3, or divided by 3. In this case, your arc length for GH is 23.03, and that's in centimeters for this case. So pretty simple way to do it. Sometimes you'll be given the arc length, though, and you'll be asked to find for something else. For example, here we're asked to find the circumference, and we do know the arc length of xy. In this case, it's 4.19 inches, and we know the arc measure is 40 degrees. So we can say that it might be easier to use our proportion this time with the two fractions set equal to each other. So we can say the arc length over the circumference, which we don't know, equals 40 over 360, and cross multiply. A couple things I would mention here, though. Instead of writing 2 times pi times the radius, we could just write capital C for circumference, since that's what we're solving for. We're not solving for the radius, so no need to have radius in there. And we can reduce 40 over 360, and that's 1 over 9. So we can cross multiply, and 4.19 inches times 9, we end up with a circumference of 37.71 inches. So using the portion and the degree measure, we can find the whole thing. And that makes sense. If this is 4, then it seems reasonable that the entire thing could be about 37 or 40. There could be about 10 of these little slices throughout this. So that makes sense. For B, we're asked to find the arc measure. So in this case, we know the arc length is 44 meters. We're told the radius, so we can find the circumference, 2 times pi times 15.28. That equals the arc measure, which is in degrees, over 360. And if we take 2 times pi times 15.28, that equals about 95.96. And if we cross multiply 44 times 360, and then divide by our 95.96, we end up with an arc measure of about 165, that's a bad looking 5, but there it is, 0.07, and that's in degrees. That's the measure of this angle here. That makes sense. This angle is obviously obtuse. It's almost a straight angle. It's almost 180. And 165 is pretty close to 180, so it makes some reasonable sense. So that's a brief overview of this section. If you have questions or comments, please email me or see me before or after school.